electricity lessons for Canada from Hawaii. Really? Hi, I'm Michelle Sterling for Friends of Science Society, and today we're going to review a CBC story that recently ran wherein they thought they could tell us something, we could learn lessons from Hawaii about clean electricity standards. So let's go and have a look at that article right now, and we'll see what you think. So what's wrong with this headline? Canada is developing a clean electricity standard. Does Hawaii have lessons for us? And then it goes on to say, Canada has just 13 years to achieve a formidable task, practically erase its electrical emissions while growing the grid to displace fossil fuels, powering its cars, homes, and factories. Well, let me tell you, CBC is gaslighting you. Gaslighting. Gaslighting is a technique that undermines a person's perception of reality. So most of this presentation will center on reality. Here's Canada compared to Hawaii. Hawaii's population is 1.42 million. Canada's population is more than 38 million. And you can see Hawaii is just a tiny little dot on the map. Hawaii is about the size of the GTA, the Greater Toronto Area, which actually has more than 6 million people compared to Hawaii's 1.4 million people. So we're not comparing apples to apples, are we? And let's have a look at weather conditions. The weather in the Hawaiian Islands is very consistent, with only minor changes in temperature throughout the year. There are really only two seasons, summer and winter, and the average daytime summer temperature is about 85 Fahrenheit or 29 degrees Celsius, while the average daytime winter temperature is 78 or 25 degrees Celsius. Temperatures at night are approximately 10 degrees Fahrenheit lower than daytime. Well, and look at Canada. There's a 50 degrees Celsius seasonal range in temperature here. That's a deal breaker in terms of renewables and Hawaii. And why do Canadian snowbirds go to Hawaii? Well, isn't it self-evident? And how about solar insolation? Now when I say insolation, I'm not talking about the stuff you put in walls and ceilings. I'm talking about the solar radiation onto some object. And this is a map, you can find it online, where you can go and see what the solar insolation is in your part of the world. So let's look here at Honolulu. And here are the stats for Honolulu. This is where it is, out in the middle of the Pacific Ocean. And it's quite near to the equator, actually. So that means that the days, the hours of daylight, sunlight, are pretty consistent throughout the year. Meanwhile, Canada is part of the Continental Plate, and we're closer to the North Pole. The best solar insolation in Canada is in southern Alberta. Brooks, Alberta, is one of the sunniest places in Canada. But if we take the solar insolation map and the stats and we compare them side by side, you can see there's a huge deficit of direct normal irradiation, and there's a difference of about 600 kilowatt hours per square meter between Honolulu, Hawaii and Brooks, Alberta. And Brooks is supposed to be the sunniest place in Alberta. So that's our first clue that their renewables plans will not work for us. And here are some quick facts from the US Energy Information Administration. So even though Hawaii was the first state to set a deadline for having 100% of its electricity sales come from renewable energy, which is required to be achieved by 2045, in fact, Hawaii runs mostly on petroleum. Most of its energy consumption is petroleum, and it is the most petroleum-dependent state. And Hawaii has the highest electricity retail price of any state, which is nearly triple the US average rate. So that doesn't sound very promising. So Hawaii runs on fossil fuels. You can see here that Hawaii energy consumption estimates for 2020 are coal, motor gasoline and ethanol, distillate fuel oil, jet fuel, HGL, residual fuel, other petroleum, and we have other renewables here, which is a nominal accumulation of all of these. And in this graph, which is a bit out of date, from January 14th to December 2016, but probably still pretty valid based on these numbers, you can see that petroleum is the leading provider of electricity generation on Hawaii, the Big Island. So in the CBC story, though, they present the renewable energy use of Hawaii as if it's something really fantastic and as if Canada's just not keeping up. So they say Hawaii's percentage of its total electricity grid is about 6 times that of Canada's percentage of its grid, not 6 times the total amount of energy produced. So that's a correction that they made. And then they also note here, these percentages do not include hydropower. So we'll see later why that is so critically important, especially in comparing Hawaii to Canada. And our comment on this is that this statement appears to try and make Canada appear as if it's a climate laggard, when there is no apples to apples comparison between Canada's astronomical grid demands, which are 632.2 terawatt hours in 2019, and its industrialized society and our vast population versus that of Hawaii's nominal power generation of 9,079 megawatt hours in 2020. Likewise, Hawaii is a state. It's not a country. It's a tropical island, not part of the four seasons climatic extremes on the northern continental shelf. CBC and Pembina Institute are suggesting Canada should impose national renewables electricity standards using a US tropical island state as the model, a state that runs on fossil fuels. So Hawaii, net electricity generation by source. Again, we see petroleum is the main driver. We see here in this graph that I showed you before that there is a large component of petroleum that drives the electricity on Hawaii, the Big Island. And the Hawaii EIA page shows that Hawaii's net electricity 2020 generation is 9,079 megawatt hours, or 0.2% of US output. So that's pretty small when you compare the US generated output is 4,176 million megawatt hours. And we do see over here in this map from 2020 that they are planning to add lots of solar to this island, which probably is a good idea. It probably will offset some of their petroleum needs, and that's probably quite significant for this island, which has to import all of its petroleum to power its electricity. But that's not the case for Canada. And again, we see there's just no apples to apples comparison. Now, wind and solar need lots of land. So even though the Hawaiians have this dream of 100% renewable by 2045, where do you think they're going to put it? Because they don't have a lot of land. And this is comparing the Greater Toronto Area to Hawaii. So you need lots and lots of land for wind and solar. And what about geothermal? Well, they did have a geothermal plant on Puna, and it provided about 30% of their electricity, but that was prior to the Kilauea eruption. So the Kilauea eruption in 2018 meant that all the boreholes had to be plugged before rivers of lava overran the facility in order to prevent the escape of deadly H2S gas. And the other factor is many Hawaiians hold traditional beliefs of the volcanic goddess Pele, and some were not very happy about geothermal tapping into the earth. But now let's look at Canada. So this is the total energy supply in Canada. This is from the IEA, the International Energy Agency. You can see that we also run mostly on oil, natural gas, coal, nuclear and hydro, biofuels and waste. And what's this tiny little line here of lighter yellow? Well, that's wind and solar. So we sure don't run on that. And we generate a lot of electricity compared to Hawaii. In 2019, Canada generated 632.2 terawatt hours of electricity. And 1 terawatt is 1 million megawatts. So here is a graph, also from the International Energy Agency, of our energy supply by source, the generation by source. So you can see that coal is declining, but it's still substantial. There's a little bit of oil, natural gas, of course, very important, some biofuels, some waste, which is some little tiny line here, nuclear, which is quite obvious, and hydro. Ta-da! We're like a huge hydro producer in the world. Clean energy, folks. And then down here at the very bottom, you see a very thin little purplish line. One is tidal power, one is solar PV. The wind is the white section under that, and then there's some other sources. So I'm assuming the other sources of kind of blue here would be maybe pumped hydro. So in the CBC story, they say natural gas poses a substantial threat to Canada's net zero goals. That's ridiculous. So in 2020, Canada had the 4th largest installed capacity of hydropower in the world. So there we are, 81.4 gigawatts. And here's a picture of the James Bay Dam. It's massive. And then if we look at the two different places, Hawaii by industry versus Canada, you can see the main industries in Hawaii obviously are retail, trade, transportation and utilities, leisure and hospitality, government, private health and education, professional business services. Meanwhile in Canada, real estate and rental and leasing, manufacturing, mining, finance and insurance, construction, healthcare and social assistance, all these things here, they need lots of energy. So we're a manufacturing and a resource extraction nation. We need lots of energy to do that. So mandating renewables would equal billions for blackouts for Canada. And looking at the CBC report, they say, unlike the state-based standards in the US, Canada's incoming national standard could provide a unifying role in a country where electricity is controlled provincially. Jaya Kumar of the Pembina Institute thinks that a policy signal is particularly important to support building interprovincial transmission to harmonize regions' renewable energy capacity. The investments needed in doing something like this requires a national level effort, she said. Well, we invite everyone to read our report, what you really need to know about renewable energy that the Pembina Institute won't tell you, because as usual, they're misleading the public. A national wind hydro grid? No, hard no. Here's a very popular study, which almost all of the main activists have picked up and run with, by Dr. Danny Harvey, proclaiming that wind energy could displace existing fossil fuel and nuclear electricity generation. Now, just to know how much this gentleman dislikes our point of view on climate and energy policies, he was one of the signatories of the eco-justice complaint with the Competition Bureau trying to shut us up, and I wonder why. Well, perhaps because we had actual working power and generation engineers do this review of the idea of a national wind hydro grid. So the biggest risk would be national blackouts. The parameters are impossible and the costs are ridiculous. So we have this in both French and English on our blog. You can have a look at it. And also, it turns out it's not so simple or free just to try and hook up hydro to wind power across Canada. And this is kind of a preliminary analysis of design considerations of a real-world interprovincial energy corridor transmission line. And this was done by a professional engineer. And basically the upshot is the Albertan consumers are used to an average price based on the ISO reports of about $30 a megawatt hour. A megawatt. This was done a couple of years ago. Prices have gone up because the natural gas has gone up as a global commodity. But asking them to pay an almost 500% premium over that to justify constructing and connecting the concept line would appear to be fraught with difficulties. Yeah. So this is one of our billboards. Wind and solar always raise the price of power. They're not free at all. The price of power will go anywhere from 3 to 9 times the cost of conventional power. Another thing that activists like Binu of the Pembina Institute don't think about is that actually Quebec hydro resources are not unlimited and neither are BC's. So this is an article from the Financial Post by Jean Michaud and Germaine Belzile, and they're pointing out that even trying to run an EV policy in Quebec in winter, you'd need almost the same as the province's peak demand in winter just for the EV policy. So they're going to run out of power the more EVs they put on the grid. And another example from BC in 2019, they ran out of reservoir because they didn't have, it was a record low levels over winter, and challenges related to the Enbridge gas pipeline explosion. So they were running out of hydro in BC. And this also happens frequently during El Nino years. They often run low in their reservoirs. So this is the problem with trying to rely on, when you're trying to rely on someone else's hydro to back up all of your needs. You can't control hydropower. You don't know if it's going to be a big snowpack this year, if you're going to have enough rain. So you can't really afford to just run that hydro out. That's probably what happened in Venezuela just before the collapse, the economic collapse started there, because they were using their hydro to back up some renewables, as I understand it. And I think Joanne Nova also noted something like that happened in Tasmania as well. So, you know, you can't count on hydro being there because it too is weather driven. So, you know, you've got weather driven wind and solar backed up by weather driven hydro, and you expect it to run a national grid 100% of the time with reliability and affordability. It's not going to happen. You're going to put everybody at risk. That's the problem. So why not store wind and solar excess power in batteries? Yeah, that's a good question. Well, this is from a blog post that we have done by one of our professional engineers. And he's referring to an article in the Calgary Herald and referencing a dozen homes and what their supply needs would be for solar and batteries only in Alberta. So here's a picture of TransAlta's 16 million 20 megawatt hour battery energy storage facility, which is near Pincher Creek and now in operation. According to the Calgary Herald article from which the picture is taken, the project consists of 3 Tesla lithium-ion battery storage groupings and is slightly smaller than a soccer pitch. So the cost of battery backup for each home's solar energy system would be $1.3 million, and that would have to be repeated every 10 years, which is the expected battery life. Now imagine one of these for every dozen homes in your neighborhood. So it's certainly not going to be very efficient for Canada. And I don't know what kind of space they'll need in Hawaii, which is quite a small state. And of course, the other thing that is only mentioned at the beginning of the CBC story, but not gone into in detail, is that for the electricity vehicle standard in Canada, this would require 10,000 additional megawatts in power generation. So there's no additional power generation projects on the table, and we would have to build at least 8 more of these projects like Site C Dam or Muskrat Falls. So that would cost hundreds of billions, perhaps trillions of dollars, because you also have to build all kinds of high voltage transmission lines, and that's not going to happen. And of course, since I mentioned geothermal for Hawaii, which sits on active volcanoes, and is made up of volcanoes actually, what about it for Canada? Well, we have this report that our professional geoscience team did. As with many nature-driven power generation proposals like wind and solar, proponents often say that geothermal will tap into free energy from the earth. A study by Majorowicz and Grasby indicates that geothermal energy simply cannot compete with power generation provided by conventional fossil fuels, and the costs are exorbitant, except in certain unique geographic situations. The best geothermal resources are far from urban hubs, which means you have to build either transmission lines if you're using it for power generation, and it would be impossible to build appropriate piping if you were trying to use it for heat. And Canada's extreme temperature differential compounds these challenges. And just to point out, US EIA is the largest producer of geothermal in the world, but it still only provides 0.4% of power generation in the United States. So carrots and sticks don't change physics. And here's Binu of the Pembina Institute, and she said the federal government's promised clean electricity standard, which aims to support a net zero electricity grid by 2035, will send another clear signal to investors and will incentivize spending on grid upgrades and intertie projects. What this is going to do is put regulatory carrots and sticks to make sure the grid decarbonizes, Giacomo said. This is how policy can be really impactful. Well, I don't know if people have been following what's happening in the UK and especially in Germany, but these kinds of very stringent green regulations are actively destroying both of those countries and may in fact lead to the total destruction of Europe if the conflict between Russia and Ukraine is not resolved soon, because they just don't have enough power and they don't have enough natural gas for heating. So people are going out of business because power prices have spiked astronomically, and a lot of people will probably die from heat or eat poverty this winter, because I don't think they can turn this situation around in time. So putting in stringent carrot and stick policies is a ludicrous idea if the physics are not there, and the physics are not there. So we have to actually ask the fundamental question, why are we doing this at all? First of all, Canadian GHG emissions constitute a tiny part of global GHG emissions. So if you look here, China emits in 1 month about what Canada emits in a year and a half. And let's look at some other statistics. The annual emissions from cigarette smoking in communist China is 36 million tons CO2e equivalent, which eclipses Hawaii's 21 million tons CO2. The entire CO2 emissions from domestic Canadian livestock is only 8 million tons CO2 equivalent. And yes, it's true, as a tiny island state, Hawaii may benefit from some renewables, because of course it would reduce the cost of importing petroleum. But Canada is not tiny. We're not an island. We're in a critically cold, hot climate. We are a producer and manufacturer of goods that require high quality, affordable, reliable power that only conventional sources can deliver, that being coal, natural gas, hydro, and nuclear. And likewise, Canadians need reliable, affordable power to survive the seasonal extremes of temperature. So why do so many Canadian snowbirds spend Christmas holidays in Hawaii? Well, let's see. Sun, tropical warmth, seas. In 2019, prior to the pandemic, a total of 500,000 Canadians visited the Hawaiian Islands. And going back to the CBC story, it's interesting that CBC never takes any critical view of things that they're told by these environmental groups. So here we have a foreign funder, the Energy Foundation, granting over $500,000 US to the Pembina Institute to support education and outreach to build a clean energy future. So these are foreign-funded interests interfering in Canadian energy policies. That would seem to be some kind of a conflict of interest, but this is never mentioned in the CBC story. And there's lots of material on the foreign funding. In fact, we just have to look at the Alberta inquiry at the Deloitte report. And this is a piece by Robert Lyman summarizing the Deloitte report. And he asks, has no one read it? Over the period under review, 31 ENGOs, environmental groups, accumulated over $2.5 billion in assets. They received $897.5 million in foreign funding and received $2.1 billion in government funding. Environmental law organizations, as a separate group, accumulated almost $11 million in assets, had foreign funding of $21.5 million, and received $7.8 million in government funding. CBC claims that they provide accuracy, fairness, balance, impartiality, and integrity. This is part of their journalistic standards and practices. And they say that the JSP is not merely a guide for the people who work at CBC Radio-Canada. It is a key component of our promise to Canadians that the work we do is first and foremost a public service. So is it a public service to mislead the public, as we've seen that this report does? Just a reminder, CBC receives over $1 billion in annual funding from Canadian taxpayers. And how much is $1 billion? Well, here's $1 million in packets of $100 bills in packs of $10,000. And here's $100 million in the same extrapolated groupings. And here's $1 billion. So that's a lot of money to mislead the public, isn't it? And we should also ask ourselves, and so should CBC be asking and answering for the public, what is the value of clean electricity? Well, this report by Professor Michael J. Kelly shows that the energy return on energy invested in solar and wind is below the standard to support basic society. And even Google engineers say that renewable energy won't solve the climate change crisis. So why are we doing this at all? Especially when CO2 is not a control knob that can fine-tune climate. So we've got quite a few additional resources. This report we did a couple of years ago, but it's still quite comprehensive and explains the difficulties of wind and solar, particularly in Alberta. This is one that we submitted to the federal government on the Clean Electricity Standard, and it discusses the problems for Canada. And this is really a critique of the Pembina Institute's understanding of renewable energy. they're really misleading the public. And as you saw in this story, they are not providing appropriate context and making comparisons that are simply ludicrous. Ultimately, renewables triple or even send your power prices up 9-10 times. If you look at the prices in Europe right now, it's astronomical. And a lot of that is because they have so much renewable on the grid, and they're paying subsidies for those renewables that really don't deliver power when you need it. So that's the quick overview of what's wrong with that CBC story that's gaslighting people. This is about us. We've been doing this for about 20 years, and we find that the sun is the main driver of climate change, not carbon dioxide. And we've got lots of material on our website about that. We're now entering our 20th year of operation, and we are asking people if they like the work that we do, if they support the information that we provide to the public, if they would just make a $20 donation to us. You can donate by e-transfer at contact@friendsofscience.org, or you can go on to our main website and make a donation or become a member. So whatever the case, we'd like you to share this information with your fellow citizens, and maybe even send a note to CBC and ask them, why are they gaslighting the public? Why are they misleading the public on these important topics? It's so important that we don't make a mistake here, because we can get into hundreds of billions of dollars of debt, national blackouts, and we won't be able to find our way back. We'll be stuck, just like Europe. So please share this with your friends. Share this with policymakers that you may know, and please support Friends of Science. Help us educate the public. For Friends of Science Society, I'm Michelle Sterling. Thanks a lot for watching, and if you want to put some comments down below, I'll be happy to answer the questions. Thanks.